Hello, this is Michelle Ashburner, and we are doing really upsetting word problems that make us feel rather dumb from our textbook today. This is section 1.1, number 43. And in case you're not using a textbook, here's the problem. A company manufactures products A and B. Very exciting. The cost of producing each unit of A is $2 more than that of B. The costs of production of A and B are $1,500 and $1,000 respectively, and 25 more units of A are produced than of B. How many of each were produced? If you're starting to cry right now, I don't blame you. This is really strangely worded, and in fact, a little bit of it is not well worded. So a little bit of it is actually worded that might lead you astray. So let's just clarify what we mean. So say we have the company and it manufactures calculators and rulers. Okay, so the first things that came to my mind. Wow, my life is exciting. So the cost of producing each individual calculator is $2 more than producing each individual ruler. Makes sense, calculators are more expensive than rulers. The cost of production of the calculators in total, like when you make all of them, is $1,500. And to produce the rulers, all of them together, it cost $1,000. And 25 more calculators are produced than the rulers. More people want calculators than rulers, surprise, surprise. And we just want to know how many of each were produced. So we're going to set up an equation and try to kind of dance a little bit around that scary wording. So I'll start by declaring my variables. That really helps me sometimes. So we're going to let Q represent the number of the B units, or I used to call them the rulers for fun, right? So, and that's because once you know Q is representing the number of these types of units, if you look up, it says 25 more units of A are produced. So then if you add 25 to the units of B, you get the units of A produced. And we need to find Q so that we can find Q plus 25, and that will tell us exactly the number of B and A type units produced. To make things easier again, I introduce another variable. And this doesn't always have to happen, but in this case, it helps quite a bit. So we're going to let C sub A be the cost of producing 1 unit of A, and C sub B be the cost of producing 1 unit of B. Then if we look here, it says each unit of A is $2 more than the unit of B. So if we're looking at the cost to make B, we add 2 to that and we get the cost to make A, because A is more to make. I'm going to let you just think about that. CB plus 2 equals CA, and then when you're ready, you can unpause the video and continue on. So here's the solution. We're going to go through it just one step at a time, no panicking. And we're going to make a couple of equations given what we know. First of all, we know that 1,500 is the total cost of making the A units, as it says up here. So if I look at how many of the A units I make, times the cost to make each of them, which in terms of CB is CB plus 2. See, that's CA, it would go there, but I just put in CB plus 2. Then you get 1,500 total. Similarly, but a bit simpler, if we're looking at the total cost of making all of the B's, then it's just Q, the number that you make, times the cost of the B's, and we'll just put the cost of the B's in there. This might be a bit weird to see. Why is this here? Why is this here? Take some time, think it out, and then join us when you're ready, or let me know that there's a question and I'll clarify it. If we solve and rearrange for 2, we get the cost BCB is equal to 1,000 over Q. So we're going to use equation 1 and sub equation 2 into equation 1. Let me get my hand out of there so you can see. So using equation 1, then we have that CBQ plus 2Q plus 25CB. So I'm just doing kind of an expansion here. And that equals 1450 because I ended up getting 50 on this side, and then I moved it over and I had 1,500 minus 50. So 1450, just to save some space. Once I sub in 2, I can get rid of the CB, and I get 1000, which is CB times Q, plus the 2Q stays the same, plus the 25 times CB, but we sub in 1000 over Q for that, and that's equal to 1450, which stays the same. So now all you have to do is magical algebra time. So you go ahead and you make some simplifications, clearing Q from the denominator so that you get 1000Q plus 2Q squared plus 25,000 equals 1450 times Q. And then you do arithmetic and you get this quadratic equation in Q. We get Q squared minus 225Q plus 12,500 equals 0. And when you decide that you're going to solve this using the quadratic formula or whatever other method you want, you get Q has 2 different answers, either 450 plus 50 divided by 4 or 450 minus 50 divided by 4. And those numbers are 125 or 100. So there's 2 answers to this question, and they're both valid. Either you ended up producing 100 of the B items, therefore 125 of the A's, or you produced 125 of the B items, and then I guess that's 150 of the A's. So both of them work. Go ahead and test them and see what you think, and then take a well-deserved break.